Okay, this lesson is on synthetic division of polynomials, and we've done long division of polynomials in this course, so now we're moving to the synthetic division. The thing about long division is it always works. No matter what, if you do it correctly, it will work and get you the same answer. Synthetic division is like an easy way to do it, and it especially is helpful when you're doing dividing by x plus a number or x minus a number, and there's not much complicated stuff to it. And it is possible to do some when you have a number in front of the x and things like that, but I'm just going to say stick to, if it is x plus c or x minus c, then synthetic division is your way to go, unless you're told to use long division. Okay, the first thing that I want you to think of is, remember that if we factor a polynomial, and let's say it factored to x times x minus 1 and x plus 2 and 2x minus 3. If you solve that out, if you set each piece equal to 0, x equal to 0, x minus 1 equal to 0, x plus 2 equal to 0, 2x minus 3 equal to 0, you would get these answers: 0, 1, negative 2, and 3 halves. These would be the x-intercepts on the graph. They're known as the zeros. But the relationship between these factors and these zeros, if you look, with the exception of the 0, obviously x equals 0, you're done, the sign has changed. So this was a negative 1 in the factor, it's a positive 1 as a 0. It's a positive 2 in the factor, it was a negative 2 as a 0. And then this was a negative here, and that became a positive 3 halves. And this is kind of like that x factor factoring going backwards. If you swung that 2 back under the 3, you would have that 3 halves. So there's a relationship there. All right, we're going to work on this synthetic division now, and you may have done this before. So we're going to use synthetic division to divide these problems. What you want to do is not use the factor, you want to use the 0. So the 0 for this would be negative 3. That's what you want to put in the box. Okay, so I put the negative 3 in the box. Now, just like with long division, if we skip over anything, you're going to have to put a 0. So if you notice, this one goes from x to the 4th to x squared. So we need a 0 for the x cubed. Also, it has to have, a number on the end. If it doesn't have a number on the end, then put a 0 as well. So it not only has to have just the powers of x, but it needs to have the number as well. And anything that's missing, you put a 0 in. So on synthetic division, you just need the coefficients, the numbers in front. You don't need the x's. So what's in front of x to the 4th is an imaginary 1. What's in front of the x cubed? We don't have one, so it's a 0, 0x cubed. Then I have a negative 10x squared, so I put a negative 10 down. And then negative 2 for my x, and then a 4. And so I'm going to bring the first number down. I'm going to leave a line, make a line, kind of like you did subtraction or addition back in elementary school. You bring the first number down, multiply that number by the number in the box, and put your answer under the next number. So 1 times negative 3 is negative 3. You add whatever you have here. So 0 and negative 3 is negative 3. Then I'm going to take that again and multiply by the number in the box. Negative 3 times negative 3, positive 9. When I get to this step again, I'm adding. Negative 10 and positive 9 is negative 1. When I go to the box, I'm multiplying. Negative 1 times negative 3 is positive 3. Here I'm adding, so negative 2 and 3 is a positive 1. Then I'm going to multiply. 1 times negative 3 is negative 3. And 4 and negative 3 is a positive 1. Then, to get your answer, you always start with one power less than what you had as the original problem. So this was x to the 4th. I'm going to start my answer with x cubed. So I'm going to have 1x cubed minus 3x squared minus 1x plus 1. This extra number, I usually put a box down here. This extra number is a remainder, and sometimes you won't have a remainder. You'll have a 0 here, but this one has a remainder of 1. And we talked about the different ways that that can be written when we did long division. So this is my answer, and it was a whole lot quicker than using long division. So let's do another one. All right, example 2. My 0 is negative 2. So I'm going to put a negative 2 in the box. I have 5x cubed, I have 8x squared, negative 1x, and 6. So I didn't skip anything in my powers of x this time. Bring down the 5. 5 times negative 2 is negative 10. 8 and negative 10 is negative 2. Negative 2 times negative 2 is a positive 4. 4 and negative 1 is a positive 3. 3 and negative 2 is a negative 6. And 6 and negative 6 is 0. This time, that last number was a 0, so I don't have a remainder this time. I had a problem that was an x cubed, so I'm going to start my answer with x squared. So 5x squared minus 2x plus 3. You use the sign of the number here. And so that is my answer in this case with no remainder. Now that you know how to use it, let's talk about how to use it to factor. We want to show that these are factors of this and then find the remaining factors. So what you want to do is, with the factors that you are given, figure out what the zeros would be. So in this case a positive 2 and in this case a negative 3. You're going to do synthetic division with each of those and just keep working it down, and I'll show you what I mean in just a minute. And then you're probably going to be left with something that you can work with and find those remaining factors a different way. So I'm going to start with the 2, and I'm going to do synthetic division, and I'm not missing anything, so I'll just use these coefficients. And so I bring down my 2, multiply, get 4, add and get 11, multiply and get 22. Negative 4 and 22 will be 18. 18 times 2 is 36. 36 and negative 27 is 9. 9 and 2 is 18. You should always get a 0 over here and have no remainder if they told you that these are factors of the polynomial. So if you didn't get a 0 with one of the ones that you were given, then you've done something wrong. Now, the nice thing is I don't have to start with the beginning stuff again. I can actually go and do synthetic division with a negative 3 with the numbers I have here. So I'm going to ignore that 0. I'm going to just continue this on and make another little box right here and do synthetic division with this. So I'm going to bring down the 2. 2 times negative 3 is negative 6. 11 minus 6 is 5. 5 times negative 3 is negative 15. 18 minus 15 is 3. And 3 times negative 3 is negative 9. And again, I get a 0 here, as I should if it is truly a factor of this. And that's a way to test if something is a factor, if you ever need to know that. Now, I'm out of zeros, but let's see what we have left. In our original problem, we started with x to the 4th. So in that first line, we would have started with x cubed. And so if we did synthetic division again, we should start the next line with x squared. So I have 2x squared plus 5x plus 3. And they told us to find the remaining factors. So I'm going to see if this will x factor. 2 times 3 is 6, and then I need a positive 5. So is there something I can multiply to get 6 that will add to get 5? And that will be 2 and 3. So that will be x plus 2 and x plus 3. But because I had the 2 in front of my x squared, I need to divide by 2. Here we will reduce to x plus 1. And here, since it didn't go in, I'm going to swing it to the front and have 2x plus 3. So if I had to factor this polynomial out, I would have x minus 2, x plus 3 that they gave me, x plus 1, and 2x plus 3. In fact, if I multiplied all that out, I should get that polynomial that they have given here. Okay, so let's do one more of these. We're going to show that these are factors and find the remaining factors, and this happens to be an x to the 4th again, but they're not all x to the 4th. So my zeros here are 1 and 1/2. And again, that might be written and not as x minus 1/2. The same thing right here could be written as 2x minus 1, but it would still be a 0 of 1/2. So just keep that in mind. This is the same as this. Alright, so when we go to do synthetic division, I'm going to use the 1 first. I didn't jump any powers, but I don't have a number on the end, so I need to put a 0 in for the number. So I'm going to use 1, -1, -2, 1, and then a 0 for the plain number. Bring down the 1. 1 times 1 is 1. When I add, I get a 0. 0 times anything is 0. -2 plus 0 is -2. -2 times 1 is -2. Add and get -1. Multiply and get 1. And I didn't get a 0 here, so I know I've done something wrong, and I have checked over my work from my personal notes and realized that this problem should have been 2x to the 4th. So let's erase most of what we have here and just change this 1 to a 2. I just typed the problem wrong. There's not going to be something like this that happens when you're doing these. It's just an error on my part, and I'm not going back to redo everything. So this was supposed to have a 2 here. Just go with the flow, please. Alright, let's bring down the 2. Multiply by the 1. I'll get 2. When I add, I get 1. When I multiply, I get 1. -2 plus 1 is -1. When I multiply, I get -1. When I add, I get 0. 0 times anything is 0. And 0 plus 0 is 0. So that did work out. And my typo is fixed. So I got a 0 like I was supposed to. I've used this. It is one of the factors and one of the zeros. Now I'm going to use the 1/2. So 1/2 here. And again, it might look like this in a problem, and it might look like this in a problem, but the 0 is 1/2. I'm going to bring down the 2. 2 times 1/2 would be 1. 1 plus 1 is 2. 2 times 1/2 is 1. -1 plus 1 is 0. 0 times anything is 0. And 0 plus 0 is 0. That leaves me with these coefficients, and I have to see what power I'm on. So I started with an x to the 4th. The first time I did synthetic division, I would be down to x cubed. The second time I would be down to x squared. So this will be 2x squared plus 2x plus 0. And so I'm not going to worry about that so much. I'm going to think about how would I factor 2x squared plus 2x. And there's a GCF of 2x. If I take that out, I have x plus 1. And so then I can look at my factors and write them all if I needed to. These are my remaining factors, 2x and x plus 1. So all of my factors would be the 2x and the x plus 1 that I found, the x minus 1 that was given to us, and either the x minus 1/2, or if we wanted to write it as 2x minus 1, we could. So these would be the factors all together that would produce this polynomial. These are the missing factors. This is a synthetic division that shows these two are factors. And that concludes